Hey everybody, Mr. May here. I'm going to show you some homework problems so that way you can complete it, but I'm not going to do all of them, so please complete the remaining problems. And just a reminder that use your notes to help you answer these questions, use the video lessons, and also on Mondays at 10 a.m. there's a live Google Meet synchronous meeting with me and Miss Warwick. So bring questions then. If you need questions answered quickly, bring it then and we can help you out. All right. In our Google Classroom, we post a link so you guys can access it. So be on the lookout for that around 9:30 tomorrow for a 10 o'clock synchronous meeting. Or I guess on Monday, since you may be watching it another time. But anyway, so I'm going to answer number 2 here. To answer number 3, you need to get these guys to be the same. So when you look at number 2 and how we come about solving it, use that same idea to answer number 3. But the notes has problems that are just like number 3 as well. So what we're going to do is we need to make sure that these two guys are the same number. So we already had the left side as 9 to the p power. And what we can do is change 81 so it is 9 to the second power. Okay, as you can see, the bases are now the same, and we're going to just set the exponents equal to each other, because that is the rule from from day 4, part 1 notes. And there you see that p equals 2 is our final answer. There's going to need to be more work done to answer number 3, but that's the idea behind how you solve equations such as these. All right, so refer to the problem I just did and the notes and the videos to help you with 1 through 3. Moving on to 4 and 5, you're going to need to eventually use the scientific calculator, or you can use Desmos to answer the problems, but we'll get to it. I'll let you know when that happens. But we need to isolate this guy here. So that means that the 2 needs to move. So we have 10 to the m plus 6 is equal to 67. And what you will do now is to get rid of this base 10, you will take the log. And since log base 10 is just log, I don't need to have the 10 there. So, oops. So we have log and we have log. Okay, this will eliminate the 10 on the left side, and you have m plus 6 equals log of 67. This is where you need to use Desmos, or the scientific calculator. Remember that in Desmos, to find log in Desmos, you need to go to the graphing function, all right, which looks something like this. All right, as you can see, I already did the problem here, but to do it again, I'll show you that you need to go to functions. So you click on functions, make sure your keyboard was open to begin with, and then you log. If you had a different base, so if it was like 3 or 5, you would select log of A, but since 10 is log, then there you go. Type in 67, and it's 1.826. Since we need to round to the thousandths, m plus 6 is equal to 1.826. And now solve for m, and m is equal to negative 5.826. Plug this back in for m in the original problem, and you should get 65 at the end. But for number 5, it's very similar. It's almost the exact same thing, just now you have a different base there, so you make sure you select log of A in the functions for Desmos. Or if you have a scientific calculator, you'll follow the steps for that. All right. Moving on to 6 through 10. I'm going to do number 6, and I'm going to do number 8. For number 6, as you can see, you have the same log base 8 on both sides. That means that you can eliminate them, because if you raise it by 8, it eliminates them. And you have 6 minus 5p equals 3p minus 2. Okay? So bring the p's to one side, bring the numbers to the other side. So I'm going to bring the 2 over here, so we have 8. Now I'm going to bring the 5p over here, so that makes 8p divided by 8, and p is equal to 1. If you're going to answer number 7, you will have a quadratic at the end of that, which means that natural logs will disappear, and you have m squared plus 73 equals 17m plus 3. You need to bring these guys to the other side, set it equal to 0, and then factor. Make sure you check for extraneous solutions, ladies and gentlemen. Okay? For 8, 9, and 10, I'm going to do number 6. I'm going to do number 8. I guess I love the number 6, but I'm going to do number 8. To answer 9 and 10, you need to condense, okay? Since they have log base of 5, 4 plus log base of 5, 2x, you need to condense them so there's one log in there. Same thing for number 10. You need to condense so there's one log. So remember the rules for condensing when you have addition between the logs and subtraction between the logs. You can refer to the practice problems from the notes from the previous days. But I'm going to do number 8 here. All right, so we need to isolate it, so because we have one log, so we just need to isolate it. So I'm going to subtract 9, and now we have log 6r is equal to 1. Remember, since there's no base visible, that base is 10. So if you raise both sides by 10, or treat log 6r as an exponent, treat 1 as an exponent, and you can eliminate 10. We eliminate the log there, so you have 6r is equal to 10 to the 1, which is just 1. Now divide both sides by 6, and we have r equals 1, 6. Okay? So again, you need to condense for 9 and 10. So for example, we have log base of 5, 4 plus log base 5, 2x. That makes log base 5 of 4 times 2x, because remember, plus meant multiplication. And hopefully from there, guys, you can take it away. Okay? So again, use the notes to complete the remaining problems, use the videos, and if you have any additional questions, feel free to email us or join us for the 10 a.m. synchronous meeting. All right? Catch you guys later.